Welcome to the module on array. In this module, you will learn about array processing in order to arrange similar objects systematically. After going through this module, you will be able to declare and define arrays, explain different array methods used in Python, explain NumPy module, use NumPy arrays, describe indexing and slicing using NumPy, and manipulate ND arrays. In the previous chapter, you learned about strings, a significant data structure and type. However, there is one prominent data structure in Python, which is vast and complex, and it is called array. An array is a collection of homogeneous values. It is a type of data structure that stores values of similar data types sharing a common name. Like strings and integers in Python, arrays are not fundamental data types. To use arrays, a user needs to import and declare an array as shown in the example here. While declaring the array, the statement includes the following elements. Array identifier name is the name of an array. Type code indicates the type of array. Initializers are the final values with which array is initialized. Type codes are codes used in Python to define the type of array values or the type of an array. The table shown here provides all the available type codes in Python. Let's take a look at a simple program using array. In the program, an array named myArray is created, which has 5 elements of integer type. The type code used is I. This type code represents a signed integer with size 2 bytes. On executing the program, the 5 array elements are printed. An array also provides certain methods that belong to an object of a class in Python. Like strings, array methods are also useful for taking arguments and returning values. The table shown here provides some of the array methods used in Python. Let us now learn how to add new elements to an array in Python. Look at the program on the screen. We have created 2 arrays of numbers, with names myArray1 and myArray2. We have applied various array methods on these, such as append, insert, extend, and from list. In Python, you can also remove an element from an array. Let us look at the following program and understand how to do it. In the program, we have used 2 methods, remove and pop. If you wish to remove an item from an existing array, then you can use either remove or pop. The method remove takes only one argument, that is the item to be removed. On the other hand, the pop method also takes one argument, but it is optional. When the argument is not supplied, it will remove the last element. NumPy stands for Numeric Python. It is a full-fledged Python package or library containing objects of multi-dimensional array and routines for processing these arrays. NumPy is an open-source project with many contributors, with Travis Oliphant as the primary creator of the NumPy. It started in 1997, when Jim Huguenin developed Numeric, the ancestor of NumPy. Using NumPy, you can perform mathematical and logical operations, operations related to linear algebra, and Fourier transforms and routines for shape manipulation. While with the NumPy, Python has the following advantages: efficient computation of multi-dimensional arrays, fast precompiled functions for mathematical and numerical routines, and it is designed for scientific computation. Without the NumPy, Python has the following advantages. It supports high-level number objects such as integers and floating point. And it has easy and cheap insertion and append methods. The NumPy module has one significant object called ND-array, or n-dimensional array type. Each element in an ND array is allocated the same size of memory block, and is an object of a data type object called dtype. The basic ND array is created using an array function in NumPy as shown in the example. The parameters used here are shown in the table. For creating an array using NumPy, first you need to import it like any other module. Let us look at the syntax to import the NumPy module. Here, import is the keyword, and NumPy is the name of the module. NumPy is renamed to NP. This is the usual practice followed by the programmers. Let us now look at the code for creating an array. Here, R is the name of the array being created, and array is the predefined function in the NumPy module. The program shown on the screen converts the given array into Fahrenheit values. In the program, first we have imported the NumPy module. Then use two variables, carray and farray. The variable carray is the array containing Celsius values, and farray is the array containing the converted values. As discussed earlier, NumPy is a package comprising different routines and functions for processing multi-dimensional arrays. These routines enable programmers to manipulate items in ND array object. The classification of routines is of the following types: changing shape, transpose operations, changing dimensions, joining arrays, splitting arrays, element insertion and deletion. Syntax for each of them is shown here. Go through them in detail. An array can be split into multiple subarrays using the split built-in functions. This function breaks the array into subarrays along a specified axis. Its syntax is: here, R represents the array to be divided. Indices refers to the integer specifying the number of equal-sized subarrays. Axis refers to the axis along which array is split. By default, it is 0. Next is hsplit function. It splits an array into multiple subarrays horizontally. Its syntax is: and vsplit function, which splits an array into multiple subarrays horizontally. Its syntax is. The program here illustrates splitting arrays operations. The summary of the module on arrays is displayed on the screen. I will pause for a few seconds to allow you to read it. Internalize this information and apply it to master the information. Thanks for watching the video. Let us move ahead with next video.